Okay, so let me grab my calculator. So we're going to be playing with a little fancy E. They call that Euler's number. And I won't get into a lot of detail about it, but it's almost a horizontal asymptote that certain graphs approach that deal with interest type problems. So if you get into business, they'll probably talk about it a whole lot more. We're just going to evaluate it in here. So, and it's a never-ending decimal, just like pi and some of those. But on the division key, you'll see a blue E on your calculator. Or yeah, if you got an older calculator, but all y'all are pretty new. So there's a little E right above the division sign. So all we do is hit the second button and then the division sign and pull the E on the calculator. So if you want to see what E is by itself, we just hit enter on that. Oh, and I'm getting approximately 2.71 828, but it goes on forever. Bring that little E is after the division there. And it's sort of like a constant like pi. So we're just going to use the calculator to approximate it to 4 decimal places. Okay. And then I'll show you there's one on there that you can use to get the exponent on pretty quick. So this one wants to know what is E to the third. Now, if you just wanted E by itself, you would use the little E that's above the division symbol. If you want to use the E and put in exponents, I'm going to use the E on the left side. It's right above the LN key on the calculator. And so that will let you, when you hit that button, it'll pull the E on the screen with the exponent ready. So if I want to know E to the third, I would hit second LN and then punch in my 3. And we're rounding this to 4 decimal places. Well, that's approximately 20 point
0855.
0855. All right, then I got one more. Let's see, we'll try this one. E to the negative 3.45. And same thing, and it's still true on negative exponents. When you get negative exponents, then numbers should be less than 1 on those, okay? I'll hit second LN to pull up the E. And then I got what, negative 3.45. 0.0317. Okay.
Do you put the 0 on front of the point or not?
Oh, you can if you want to put a 0 here.
Okay.
But it won't affect the MATLAB answers.
Okay.
It'll automatically assume there's a 0 there if there's no number.
Okay.
Okay. And y'all have seen some of these exponential graphs this year, if you're watching the COVID. Those exponential graphs start out slow and then they will start doubling and climbing quick. Okay? So I'm gonna graph one of these and then we're going to start playing with our transformations on these graphs. Okay? So let's just graph one of these. Y equals 2 to the x. But notice now the variable is the exponent on this graph, okay? The variable is not the number in front of that exponent, it is now the exponent. And let me get a graph started here. So one number I will use every single time I graph is still going to be 0. Now, you can use negative numbers for the exponents, but all that negative exponent is going to do is make these answers look like fractions, okay? So, put a 0 in for the x. What is 2 to the 0 equal? 1. So anything to the 0 power will be 1, okay? Which means every one of these exponential graphs will cross through 0, 1. Okay? Oh, another number that's pretty easy. I'll do a 1. And anything to the first power is basically going to be itself. So 2 to the first is going to give me a 2. Okay? And if I put a 2 in, I get a. But look how this is doubling. Okay? And then let's try one more number. If we put a 3 in there, what would I get? 2 to the third power.
9.
8. Because you're doing 2 times 2 times 2. And they give me an 8. So that's about as far as I'll go on this one because I'm running out of graph room. So 0, 1, they're all going to cross right on the y-axis unless we shift them and stuff, okay? And then at 1, we was at 2. At 2, I was at 4. So you can see now it's starting to get that curve. And then if I went up about 6, 7, 8, over here at 3, I'd already be up at 8. Okay, so now what's going to happen on this left side? As these exponents get more and more negative, it's going to get me a fraction that's going to try to approach more and more to the 0 on that. So this side is almost going to do like a horizontal asymptote, just going right down that x-axis, okay? So I'll show you what's happening with the negative exponents. So if you put a -1 in for that exponent, you would have 2 to the -1, right? So we don't like negative exponents, so we make them positive. And to make an exponent positive, you flip the number in front. So if I flip it, man, that's like a 2 over 1. If I flip it, I get a 1 over 2. So if they're on top of negative, you move them to the bottom. If they're on the bottom of negative, you move them to the top. Now, that's just a 2 to the first under a 1, so that's just going to be a 1/2. What's going to happen when that's a -2? Same thing, right? Make that exponent positive by putting it all under a 1. Put 2 to the second on the bottom gives me 4, so that makes a 1/4. And I just wanted y'all to see that this is actually getting closer to zero. If I put a -3, I get a 1/8. -4, I get a 1/16. So it's getting smaller and smaller as you go out that negative infinity, okay? And I'll do one of them with a fraction. Hang on, so on this one I'm gonna graph y equals 1/5 to the x. So these will be similar, but the exponents, since I got fractions, are going to do a little bit different than the graph I did for my tube in there, okay? But I will still use a 0. And 1/5 to the 0 power is going to equal 1. So as long as you got a 0 for that exponent, it's always going to equal 1 for that, okay? If I put it 1 in there, 1/5 to the first power is just going to be 1/5, right? So 1/5 squared would be 1/5 times 1/5. So that's what, a 1/25. So what's happening when you got fractions, they're not growing. They're getting smaller and smaller, trying to get to that x-axis. So let's see what happens on the negative side with these. So if you got 1/5 to the -1, bam, that's it. I'm just going to flip it and make that exponent positive. So this is 5 to the first, which is a 5. Even if I'm going to go one more number, how about a -2? But I probably won't graph this because what happens to that -2? Because you got 1/5 to the -2, which will be 5 squared. I'm just flipping it still, making the exponent positive. The 5 squared is now 25. So if you notice, the fractions do the opposite of the numbers. The fractions want to come down and try to get to the x-axis in the positive direction versus the negative direction, okay? But notice it still went to 0, 1 on that, okay? And then over here at 1, I'm at 1/5, which is, it's pretty close to the x already. And then y'all at 1/25, that's pretty much on the x-axis, right? So all the fractions do basically is flip these around, almost like make the mirror of itself. So over here at 1, I was at 5. At 2, I was way up here at 25. So this graph will come, oops, start shooting up. And I'll tell you what, notice, if this was like the COVID going on right now, 2 people being infected, their doubling rates pretty slow compared to if this was 5 people, they go quick, okay? That's in hot spots, right? All right, so what we're worried about is really doing transformations of these. And let me see, I did those to you on test two, right? Moving the graph left and right, up and down, and we even flipped them. All righty, so the graph of f of x equals a to the x plus or minus b. So the move I'm looking at is what's happening with these b's at the end. If I add a b, it's going to move my graph up still. And if I subtract the b, it's going to move my graph down. So plus b moves up. Negative b moves down. So that's still the same as it was in the 8.1 section. Now I'm attacking the exponent, which is the variable. And anytime I attack them variables with a number, that's going to move me left or right. This would be similar to the x's y'all had in parentheses. So if the c is positive, it's actually going to move my graph to the left. And if I subtract c from that x, it's going to move my graph to the right. And no, that's the same as it did when y'all was doing them inside the parentheses on that section. It was always opposite on the horizontal movement. F of x equals negative a to the x. So anytime I throw a negative in front of my function, it took that graph and reflected it right over the x-axis. So that's going to reflect over x-axis. But this is where I said I would add the new move to you. So f of x equals a to the negative x. That's going to reflect me on the y-axis. So basically, three of them are the same moves we did, other than we're now attacking the exponent as the variable instead of having it in parentheses, okay? And then the new move, I'll make that exponent negative, it's going to flip me across the y-axis, okay? So that's what's going to happen. I'm going to write up equations and we're going to tell sort of what moves is happening to them, okay? Now, remember, when you graph these, it's going to go back to the way you graph the problems in 8.1. You're going to click the graph you want to use, click it in the graph, and it's going to pull up in that little side panel that says move it horizontal, vertical, and then you click it if you're flipping it, okay? So we're going to see tell the transformations. And then they want us to graph. So this one has f of x is going to equal 2 to the x minus 2.
Can I ask you a question, sir? Sorry.
Mhm.
How do you know this is B or C? Can I have a column?
So B, to get a B, you'll have something like 2 to the x minus 4.
Okay.
To get the C, you'll have 2 to the x minus 4.
Oh, okay.
So one of them you're really hitting the exponent, and one you're just adding a number at the end on them, okay?
Okay.
So this would be B, and then this one would be the C. Okay? So what's happening with that -2 hitting my x up there? So this is the move I'm worried about. It's going to move me to the right 2 units. So it's going to move right 2 units. And then on these ones, they always want you to start with the graph of what you're starting with. So I started with graph of f of x equals 2 to the x. This is where math lab is different for these kind of problems versus the last section. In the bottom of the little window, when it pops up the window, it's going to ask you what is your base. Your base is the number that's being hit with that exponent. So for this one, my base would be the 2. Okay? By default, it's got the E there. So you got to change that every problem that you're not messing with the E on that. You got to put a 2 in there for the base. And then I would shift horizontal to the right 2, and that would be done. Okay? So I would be pickier on my numbers on this one. My smallest x I would probably pick would be a 2 on this one. Unless you want to deal with negative exponents, right? And then I'd probably pick a 3 and then a 4. So if we put a 2 up here, 2 minus 2 is 0. 2 to the 0 is still going to be a 1, right? So over here at 2, whoops, at 2 I'm at 1, right? I put that on 1. So at 2 I'm at 1 because 2 minus 2 is 0. 2 to the 0 is 1. If I put a 3 in here, 3 minus 2 is 1. 2 to the first power is. So now with 3, I would be at 2. But see, you can already tell I moved right twice, right? Because this point at 1 should have been on the y-axis, but it's now moving me to the right twice. And then if I put a 4 in here, 4 minus 2 is 2. 2 to the second is 4. Now, what would happen if you did use negative numbers, it's just going to make this get smaller and smaller and try to get to the x-axis, okay? Well, they're not too bad to graph, it's just keeping up with their moves, all right? All right, same thing, this time I got f of x. Let me get a good one. All this one has 2 to the x plus 3 minus 4.
C and D.
Hmm.
And C and D.
So I got both of them on this one, don't I? So, what's the plus 3 doing to me?
Moving it to the left, right?
I want to move left 3 units. All right, so what's the negative 4 doing to me? So it's going to move me down 4 units. And it looks like that was only 2 moves. So start with, so what would be my base on this one?
Wouldn't that be
So the base is still going to be the number you're hitting with them exponents. So the base is a 2, okay? So it's going to ask you start with the graph of, so you're going to start with graph of f of x equals 2 to the x, okay? So just remember the number that's being affected by those exponents is my base, okay? Now I'm gonna draw that, but what it would do is move it left, and then it would kick it down. It'd be in that third quadrant down there, okay? Okay, so I want to get this good one. So, all right, so we're gonna look at a formula.
another graph?
Oh no, y'all can write that on you. But all it would do is it would kick it left and then down, right? All right, I'm gonna set these formulas. So this formula, so let me write this up here. A equals P times 1 plus R over N, all raised to the N times P. This is pretty much the amount of this would be the amount in your, say, your bank account or your funds using what we call simple interest. Okay? Y'all heard of compound interest and simple interest? We'll look at compound interest at the end of this chapter, but simple interest, they just apply interest for the year, like 3%, and they charge it. Compound interest, they hit it 3 times a year, 4 times a year, or even more. So this is going to be the amount in the account. P is your principal balance or your starting amount. P. So your starting amount. R. R is your interest rate. And remember, when you put it into my formula, you better have it in decimal form. Okay, you can't keep it in percent form. You got to convert it to a decimal. Oh, you thought I some kind of thing. Oh, 93. Okay. So N is the number of compounds and then let's see, what's left is my T. T is time in years. I think every one of these T's gonna be time on them, I think. And then all this will still be the N, same N. That would use that thing. All right, so let's go through these questions. You ready? So we're going to suppose
Uncurrent is that a 1 plus
N 1 plus R divided by N. All right, so we're going to suppose 57,000 is invested at 5.5% interest. Compounded quarterly. So the words they'll use on your compounding is annually, which means once a year, semi-annually, which would be twice a year, quarterly would be 4 times a year. It's pretty much now, they might go with compounded daily, but probably not in this section. Okay. All right, so first of all, we're going to find the function of the amount the investment grows after T years. So I'm not going to get an actual amount, I'm just going to find the formula that I would use for this data so that if I did know how many years I was looking at, I can find that data. So we need to come up with this. So we know A is going to equal P. So what's my P? $57,000, there you go. So remember, that's going to be the P, because that is my starting amount. Then we got 1 plus R divided by N. So my R. So first of all, I'm going to turn that 1/2 into a decimal. So that'd be 5.5. But that's still in percent form, right? So turn that into decimal form. You want to take this decimal and move it left 2 units. So that's going to give me a 0.055. There you go. Okay. So that is now the R. So we'll put that in the formula. So I got a 0.055 divided by N, which is my number of compounds. Quarterly would be 4, perfect. And then it's 4, which is my N still, times T. So, y'all, technically, this is the formula we would use, but MathLab is picky and they want us to simplify all that's in the parentheses, because all that's just a single number in there. So we'll get A equals our 57,000. So let's see, what is 1 plus 0.055 divided by 4. And it actually should be a 1 point something. 0.1375. And then all that's go to the 4t. At that point, MATLAB is happy because we can't go no further now because we don't know what t we're putting into that, okay? But check this out. What if that t was a 0? That 4 times 0 would be a 0, right? And all this to the 0 power would equal 1, and 1 times 57,000 would be 57,000. So it works that if you're at the starting point with 0 years, you better have $57,000, okay? All right. So for part B, they want to know how much is in the account at certain years. I'm going to put up there. So how much in account after, so let's try t equals 0. Well, we know what was going to be in there. We said 57,000. So what are we going to get when t equals 2? So to figure this out, you would have in your calculator 57,000 times 1.01375, and that would be 4 times 2 now, okay? And the only thing I can say about this problem, you better get more money than you started with, okay? If your money goes down, something might be wrong on that, okay? So 1.01375, and then raise that to the 8 basically, 4 times 2. So you get around 63,000 over there. So let's see, they want us to round these to the nearest dollars. So I got 63,000, 580.
I don't get it.
So I just start out and I just put it in just like I got it here.
Oh, okay.
Yeah, these are tricky to do step by step. But you'd make that an 8, then you would raise the 1 to the 8, then take that answer and multiply by 57,000. Okay. Next one I wanted t equals 5 years. Ooh, I'm already getting pretty big. I'm getting up to 74,902. So look at that. After 5 years, I've already made a good $17,000 just by investing 57,000. Quite a bit, but still. Oh, that's right. The ones at the end of the class are continuous, and these are compounded like quarterly and stuff. At the end, it's continuous compounding, so you see those are a little trickier. All right, so 10 years. Woo, what y'all get on that? It's pretty good, doesn't it? 98, 426. So there's a good, you make $40,000 off that money in just 10 years. Okay. Well, that's one little formula. If you know you've got compounded interest, you find good investment opportunities, I guess. So how old is your little girl? You got a 6-year-old?
Yes.
Okay, so this one's 400.
Okay.
But this one's name is Melissa.
That's
So
okay.
Melissa's 6th birthday. She's lucky and she got a $6,000 CD. That earns 6% interest. Compounded semi-annually. Oh, that's one word, okay. Oh, there's no space, that's one word. No, it don't got it on here. But I would have thought so, wouldn't you? Okay, so my fact just made that one big long word. If it matures on her 16th birthday, so it matures on 16th birthday. How much money will be available?
So what is insurance? Well,
Question?
what is insurance? What does maturity mean?
It's when it's matured, that means you've ran the course of your time, and it is now time to get your money if you want to.
So it's not expiring.
Sort of like the beginning date and ending date of it, I guess. If you get them out earlier before they mature, you get penalties a lot of times, like a 10% or even 20%.
It's basically an account that is blocked for 10 years.
I did that one time, I got a penalty on something, but, you know.
Oh, I had that.
Mhm.
I took money out a year earlier
Mhm.
to move away and I got penalized.
But if they're mature, I think you can actually get them. You pay a little percent, but I don't think it's like that big penalty fee you're getting them on. All right, so I'm gonna go to my formula. No, A equals P, so my principal is 6,000. And then 1 plus R is 6%, we turn that into a decimal. So 0.06 on top of this. So N is semi-annually, which is how many? 20. So that'll be 2 for the exponent times whatever my T is. Yeah, since you got it on her 6th birthday, and it matured on her 16th birthday. So the 16 minus 6 will give me 10 years. So I guess we're about to see if little Melissa's going to get her a car for her birthday, right? Ooh, 10,000 something. Now round this to the near cents. So it looks like I'm going, what, 67 cents? We're gonna get around 10,000? So, didn't quite double her money, but boy, that gave her another $4,836. She probably have a pretty nice 16th birthday, right? Maybe.
I didn't get that.
Huh.
I didn't get that. I got 20 bucks.
More back in the 80s, I was lucky if I got $5 for this or something, you know?
16 or if we're gonna full work.
You know, the main thing today was just remember, we can move the exponential graph around just like we did the parabolas and the cubes and everything. And this formula is just get y'all used to evaluating stuff with exponents that are variables, okay? So we're not getting, that's it for today. Next class, we'll start talking about logarithms.
And, okay, so you got two things, but on the other one, it was like 4 times. Yeah,
So 4 is the number of compounds. So this one was compounded quarterly, so it was a 4.
okay.
This one was semi-annually, so that made that a 2.
Yeah, okay.
And that's probably gonna be, you know, the only thing that's really gonna change on those is how many compounds is it getting those years with. Okay? So this means over the 10 years, this is getting compounded 20 times. Some of them, that's got a 4 there, get compounded, so that would have been 40 times. That means they're adding interest that many times a year to your account, okay? So we're gonna stay away from the continuous daily. So have y'all ever done logarithms? I just want to give y'all a little quick data on a logarithm. Now, this is a logarithm. The 2 is what you call the base. The 8 is what you call the result. And all this logarithm is finding is it wants to know what exponent. So really, logarithms are exponents, okay? So what exponent would raise 2 to get 8? That's what that's asking me. That's the base. So you want to figure out how many times you multiply 2 times itself to get an 8. That would be a 3. We'll leave that on it. Watch this. What if this was a yeah, 1, right? 5 to the first power would be 5, so this would equal a 1. Hey, did you get the email about this computer?
Yes,
You can't impose on it.
I know. I stayed with Robert. I stayed with Robert trying to figure it out.
Yeah, he got done on his the one day, and I come in behind.